Hey everyone, Mr. A here. Today I am going to be trying my hand at explaining quarks. First timer here, so if you feel like anything that I said in this video is wrong or I made a mistake, please let me know. I'm still learning more about this, but I'm gonna try my hand at explaining quarks to beginners. So first let's start off with what are quarks? What are these things? You might have heard about them in your physics classes or from your friends. What exactly are quarks? Well, very simply put, quarks are the fundamental building blocks of all protons and neutrons. They build protons and neutrons. The structure of these two comes from the quark. The quark builds these two. They're inside of the proton and the neutron. So let's learn more about them. So quarks have 6 types. There are 6 main types of quarks. And these are the up, down, charm, strange, top, and bottom. Let me just redraw those two. Now, in reality, there are only 2 very important quarks for now that we will discuss. These are the up and down quarks. These are the most important quarks for now. The rest are the charm, strange, top, and bottom quarks are usually too heavy and unstable to actually be in atoms for very, very long times, which is what we're going to be talking about. They decay very rapidly. And so now that we know that there's these 6 types, and these are the 2 most commons, we now can also another thing I have to tell you is that up and down quarks are the 2 main quarks that you'll find in protons and neutrons. So how are they structured? So let's look at the proton first. First, the proton. Okay, so in protons, there are 3 quarks. The up quark, there are 2 up quarks, and 1 down quark. Now, and for neutrons, there are, for neutrons, there are 2 down quarks and 1 up quark. So why the quarks? Now, and what is holding the quarks together? So first let's answer the question of what is holding the quarks together. How come they're not just flying all over the place? And the thing that is holding them together is a strong nuclear force. The strong nuclear force. This is one of the 4 fundamental forces. And these hold the up and down quarks together. This holds the proton and neutrons together. And the proton and the neutron actually derives some of the properties, from these quarks, because these quarks also have properties, just like a neutron or an atom might have properties. So, for example, we're going to talk about, let's take the up and down quarks. What are their properties? Those are the 2 most important. For now, the up quark, for example, we're going to be talking about charges here, has a positive 2/3 charge, while the down quark has a negative 1/3 charge. And this makes sense when you take into account the charges of the proton and the neutron, because 2/3 combined is 4/3, and 4/3 minus 1/3 is 1, right? 3/3 equates to 1. While in neutrons, 2 down quarks make negative 2/3 plus another negative 2/3. Negative 2/3 plus 2/3 equals 0. Thus, the no charge in neutrons. Now, quarks can be grouped together. They can combine together, as we saw with the protons and the neutrons. And protons and neutrons are actually type of baryon. What is a baryon? A baryon is a group of 3 quarks. A baryon is a group of 3 quarks. We're going to be using Q just to represent quarks. 3 quarks grouped together is a baryon. The second major group is the Masons. Now, do know there can be multiple types of baryons, and 3 quarks can be grouped together. So if you have 3 quarks, let's say A, U, D, and C, you can group them together as one, UDD, another baryon, and so on and so forth. You have multiple baryons. Now, there's also something known as Masons, and Masons are a little more confusing, but they're basically 1 quark and not another quark, but something known as an anti-quark. So I'm going to represent it with the negative. 1 anti-quark. Now let's talk more about these anti-quarks, shall we? Anti-Q is what I'm going to call them, just for simplicity. So let's talk more about them. What are anti-quarks? Anti-quarks are basically the anti-particles of the quark. So, for example, the U quark, as we saw, and they usually have opposite properties in some and different like baryon numbers and quantum numbers, but I won't go in too depth into those. But let's look at charges, for example. Say we have the U quark, right? The U quark has a 2/3 positive charge, as we already discussed here, right? So an anti-particle or an anti-quark of this would have a negative 2/3 charge rather than the 2 charge. And that's really the basic introduction to quarks. Very much simplified. If you want to learn more about them, please go and learn more about them. If you think that this video could be improved in any way, shape, or form, then please do. Please remember to like, subscribe, and share this video, and subscribe to my channel if you want to see more content like this and see me explaining more physics stuff. Really one of my favorite subjects, just beautiful. If you have any more questions, leave it in the comments down below, and I'll try my best to answer all of them. Thank you so much, and have a great day.